All right. So, okay. So we were here. So this is one use case when many servers are there and clients need to discover one server which is alive. They use it, Zookeeper, for that. Okay. So the way it happens is that there is a Zookeeper and then there is a list of servers on the left hand side. So one server connects to Zookeeper, and Zookeeper says, okay, I'll call you when you are needed. You are now connected. Now the moment it gets finally connected, there is an event that is triggered, which is also received on this connection client side. Now this server will send a request that can you create an ephemeral node for me, and my name is Duck. Similarly, another server, okay. So here we are talking about these servers. These servers could be your process. So you are running a website on 50 servers, okay, and there are millions of users who wants to connect to your website, okay, and for that they can use Zookeeper. So, all right. So these servers inform their names to Zookeeper, say duck and cow. The way our reason servers Hadoop 1, Hadoop 2, Hadoop 3, they keep on informing Zookeeper by creating their ephemeral node. As I demonstrated to you, that if I shut down one of the reason server, the list from Hive, the hbase-unsecure slash rs, automatically the node disappears from there. Okay. So they created duck and cow. Duck and cow are created. The user comes in, it says ls/servers. It says, okay, there are two servers available for me, duck and cow, and then starts reading from either duck or cow as per the user's convenience. After 5 seconds later, the cow has been here, duck server has been offline, then this duck node which was created in Zookeeper will automatically disappear, and if 5 seconds later the client comes in and says give me the list of servers, it will only give a list of cow. Okay. Now I hope that clears it. So this we have already done. We have already done this part. So you can also try to, as a hands-on exercise for yourself, try all these things in your by connecting to the Zookeeper client. Alright, there are few more use cases such as building a reliable configuration system and a distributed log service. Okay, so there are actually many use cases for Zookeeper. Say for example, you need to have the some settings across your website, and that website is running continuously on hundreds of servers. So those kind of settings you can keep in Zookeeper, and so basically whenever you require coordination of any kind, then you use Zookeeper as a safety mechanism. All right. So keep your questions ready. We'll take 10 minutes break and we'll discuss it after 10 minutes. All right. Should we start now? All right. All right. So, is everybody able to hear me clearly? All right. Any questions related to Zookeeper so far? No questions? All right. Alright, so today we are going to further discuss a few more components such as Scoop, Flume, and Oozy. Alright, so these are, though they sound like very small tool, but they are very important tool and we should know about these tools. So what is Scoop? Scoop is an open source tool. It extracts the data from the structured data source, basically the relational database such as Oracle, Microsoft SQL, and the normal data, the MySQL, and it basically helps us to import data into Hadoop and out of Hadoop. And basically, once we have put the data into Hadoop, when I say Hadoop, it means either Hive, HDFS, or HBase, and we can export the data back into data store. It also provides an extension framework called connectors. Now, question you might ask is that what is so big deal about it? We could write our own Java program and start working on it. Correct? We could create our own Java program which will connect to MySQL or Microsoft SQL and then put the data into the HDFS. Or we could export our all data into CSV and copy that CSV file into HDFS, right? We could do that. But why would we need these tools? First, all other mechanisms, whether you are exporting data to SQL to CSV or you are using Java program of your own, is going to be fairly inefficient as compared to Scoop. Scoop uses the paradigm of MapReduce again to distributedly copy the data from SQL servers. Okay, SQL servers are generally really more powerful hardware wise, and therefore they can tolerate multiple requests parallelly. So we can have multiple requests from multiple data nodes parallelly going to same MySQL server, and that is how Scoop makes it very efficient to copy the data from relational databases to Hadoop. Okay, when I say Hadoop, Hadoop means HDFS, Hive, and HBase. Okay, so these are the basic commands, and all these commands are with respect to the the Hadoop side. So when we say export, export means exporting data from Hadoop to normal database. When I say import, import means importing data into Hadoop and from the Microsoft SQL or any other relational databases. So these are the various commands. You should have a look at it. So this one is going to be very hands-on, and yeah, this is better. So let me just do an SSH. Alright, so we are now connected to Hadoop 1, and let's say scoop help. So you can see that Scoop is also a MapReduce client, just like Pig. So it's just a client. It doesn't have much of a server. Alright, it only has this command line. It basically gives you import and export. And internally, it executes mappers and reducers. There are many connectors for Scoop. And by default, almost every database which provides JDBC driver can be used with Scoop, which means almost every database can be used with Scoop. In case some database is not compatible with Scoop, you can write the connector, and that connector will solve the problem. All right. Before copying the data from our MySQL in this database, in this sample example, what we are going to do is we are going to copy the data from our database, a normal database called MySQL. We want to copy one table into HDFS. That's our first task. Okay, so we already have our MySQL running. So okay, so we have already a MySQL running, and we can see what are the databases. Okay, so we have Scoop ex3 already, so we don't need to create this. And also note this, why we are giving so many permissions. Why? So although We are right now connected to Hadoop 1, but when Scoop runs, Scoop basically will instruct multiple data nodes to connect to our MySQL and get the data. So it's not only Hadoop 1 which will be connecting to MySQL. It can be any node out of our Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4, because all of these nodes are running our task tracker, right? So Scoop will write MapReduce job to pull the data from MySQL into the data nodes. Okay. Therefore, we need to allow Hadoop 2, Hadoop 3, Hadoop 4, everybody to access this data. And that's why I have created this file where I have granted permission. First, I created a sample database. I granted all the nodes to access the data from this sample node. All right. So on one hand, we have our traditional MySQL database containing some data. This some data we are trying to create just now. But first we created a database, then we gave permission on it, and then we created a table called widgets. I have already created a table called widgets. You can have a look at it. So you can see that this table, whatever we are trying to create, I have already created it. Okay, so this is for sample table. So we want to copy this widgets table from our MySQL database onto our HDFS. All right. So now what we can do is we can go to the command line. Okay. So let me also open one more SSH. So on one I'm running MySQL, on another I'll be running Hive. So on this second number terminal, so the first number terminal is MySQL. The second terminal is my another terminal where I'll be executing this command. So it's pretty straightforward. All I'm saying is scoop import connect to my database. This is the URL, JDBC URL of my database. You can see the database name in the URL, and Hadoop 1 is because Hadoop 1 is running our MySQL in which we have created this table. We want to import this table called widgets from this database into our HDFS. So all we need to do is we need to provide this. Right now password is empty. Okay, password is right now empty. So you can say scoop import this and run the command. It's importing the table, and let's see what happens. Let me create one more session. So on one we are running MySQL, on another we are running our scoop, on third one maybe we'll run our HDFS. Okay, so I'll talk about -m here. So scoop involves MapReduce process, right? But it has no reducer, it has only mappers. Why? Because it concurrently has to read data and write to all the machines. The mappers are basically mappers control how many nodes, how many data nodes will connect to our MySQL. So total number of mappers, if you increase, then you will have more nodes connecting to MySQL parallelly, and that is governed by -m. Okay. So it's a map reduce process in which there is no maps, it's only it's no reduce, only maps. Okay. Now it has copied the data onto our home folder. Let's have a look at it. So we can say Hadoop fs -ls. There'll be a widgets folder which it must have created. So here is the widgets folder modified on 30th May, and we can say now you can see part dash m 000. Okay, had it been part dash r, that means it was generated by reducer, but here it's generated directly by mapper because there is no reducer. Alright, so this one contains our file. We can have a look at it. fs-cat, and okay, so you can see that it is by default saved as comma separated file. Okay, whatever data we had here, uh, so whatever data we had, these three rows have been copied onto our HDFS like this. You can also look at it from the browser, okay, and it has been copied as comma separated file. Alright, so we have been able to successfully copy the data from 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 MySQL onto HDFS. Alright, also please note that in the same folder it also creates a widgets Java. Okay, and widget Java basically is a Java program that represents your data, so that if you have to automate the process, you can take the widgets.java, modify it and run it again and again to import your data via Java program. Okay, so it basically gives you the code as well, automatically generated code, which will be helpful for you. All right, so the overall idea is to help you automate the process, and that's why it has created Java program also for you. Now next is so we were successful in importing the data from HDFS, sorry, from MySQL to HDFS. Now let's say we want to create Hive table corresponding to the data which we have imported. So the way we have to do is, first we have to tell Scoop to create Hive table. We could have created this Hive table by ourselves, by manually, but that is too much error prone. Therefore, it is generally advisable to let Scoop create the table for you. Okay. Now, once we have created Hive table, we can import the recently copied data into Hive. The recently copied data, which is part dash m dash 000, we can load that data into Hive, right? Provided we have created a table in Hive. So let's create the table in Hive. Let's create the table in Hive. Okay, so the table has been created in Hive. Let's have a look at it. In case it's already there, let's launch Hive. Select star from widgets. Okay, it already has a table. Let's drop this table and create it again. Drop table widgets. Okay, and import it. So I'm creating an empty table right now. Okay. Alright. Now we have widgets table, but it has no data. Let's load the data the way we used to load using our existing Hive query. So we have loaded the data using Hive. Now in widgets we have table data. Okay, so we have provided that this is our folder, and load the data into our table. And this table we have created, and while in creating the table we have informed we have created a table which is basically comma separated one. All right, so that's the way it is. Now Manish's question is, change the change we the file format, and so do you mean can we change the file format? Okay, can we change the file format, and if I wanted to create an incremental record from the table. So you have two questions. First is, can we change the file format? So yeah, while exporting the database data from MySQL to this one, we can specify the field separator. Okay, on that basis, that file will be created. Okay, other than that, you can't do much other than providing a field separator. And if I want to do incremental records from table, yes, you can do that. Scoop provides you from that command line. If you have a look at the command line, okay, scoop help and import. So in under import, you can see all the details about whatever you can provide. Okay. You can see the incremental. All right. Hi. So extremely sorry for this. Yeah, extremely sorry for this because the network is gone. All right. So Kalyan, let's just have a few more minutes. We'll have little more things to do. Okay. And alright, so let me just finish this import and export of data. Alright. Am I clearly audible to everyone now? Yes. So Anand's question is where the data is stored while importing from MySQL. So the data is by default is stored in your home folder. You can inform Scoop to store elsewhere by providing the location. Okay. So everywhere it's in the home folder, and everywhere we have provided the relative path to our home folder. Okay. So here we are saying in path widget, which means it's in our home folder. We have not provided any absolute path. Similarly, while exporting the data here, we have not while importing the data here, we have not provided any location. So by default, it creates a home folder. Okay. Alright, so we did 3 steps in this. First, we copied the data from MySQL to HDFS in a comma separated format. Now, in the second step, what we did was we created an empty table in Hive using Scoop, and in third, we loaded the data into Hive using the load command of Hive. Okay, so we basically used 3 steps to get the data into Hive. Now we can do other things as well. Okay, we can do other things as well. You know, like if you want to import all of the data in a single step, you can use this particular command. Okay, you can use this particular command. Now let's have a look at it. Okay, so in a single command, let me also delete this file. So I'm connected to this. It says that output directory already exists. Okay, so you'll have to say hadoop fs minus rmr, and we say widgets. And also parallelly, let's launch Hive and delete this particular folder, delete this particular table, and then we'll do everything in a single shot. We can say drop table widgets. Okay, in Hive we have deleted the table, we have deleted the folder from the file system. Now what we can do is, alright, now let's just run everything in a single shot. And here we go. So this command, if you look at it, it says scoop import connect to my SQL and get this table using only one mapper, and and do the Hive import. Okay, and this is the login password for my database. So Hive import is the keyword. This is earlier we did create Hive table instead of import. So now it has imported the data. Now we can say select star from widgets, and it would be there. Okay, so both the things done in a single shot. Now going back to the question of Srinivas, can we can we is it possible to create dynamic column with data based on calculation of existing column data? Is it possible to create dynamic column of the data based on calculation of existing column of the data while importing? So Scoop does not provide you that kind of functionality, but after you have imported, you can write your pig or hive command to do that for yourself. Okay, that kind of merging it does not provide. Okay, it only provides the tasks very specific to import. If something can be done using queries later or before, then it does not provide you that. All right. Now, in the similar fashion, we can import our data into HBase. Same table we want to import into something called customer. So before that, let's launch HBase shell. So we check status. All servers are alive. No server is dead. And now we can say scan customer. Scan customer. Scan customer. So there is a table called customer, so can't we just scan it like, oh, you don't have to give semicolon actually. Yeah, so we already have one table called customer. Let's disable that table. If you remember, disable customer, disable and drop table customer. Is it? Alright, so now we have deleted the table, so it's not there. Now next is, you can see what we are trying to say is import our MySQL table into HBase database. Now if you remember correctly, in HBase table we have one thing mandatory called column family. We can create a column family here, and in this column family, a single column family, all the columns will go. Okay, also we are telling few more things, because in HBase it is mandatory to have one row ID column, right? So that is why we are telling that row key column is in the ID field. Okay, here if you have mysql.uroot, so if you see in our table there is a column called ID, and that is what we are going to use as our row key. Okay, so let me just log into my, okay, so here in the ID column is what we want to use as row key, and HBase is totally okay with it. Okay, and you can have a look at it. So we are specifying what all? We are specifying an input table from which the data will be copied along with the database. We are providing the login password for our MySQL. Okay, and then we are providing a table name in case of HBase, and also we are providing a column family for HBase, and which all columns we want to copy. It's not mandatory. If you don't mention this, then all the columns will be copied into the current column family. Okay, so this is the situation. So also you can import into the same column again and again. Okay, few columns now, few columns later, provided your row key is correct. Now let me run this. Okay, it says column not found. Alright, now let's just remove the column parts from it. And by default, if you do not provide ID, by default it looks for a column called ID. These columns are not there in the in our problem. So that's the reason it's giving error, because we have price, this, that. Okay. So it's doing the job of importing the data. So can we process the data while importing, that is, after populating the Hive or HBase table? So that processing is very rudimentary. Okay, it's assumed by Scoop that you will do processing using some other tools or after you have populated. Alright, so it is now done. So we can say scan customer and it will be imported. So you can see that now the data has been imported into HBase. This is a single column family, and these are the tables. Alright, these are the tables. Okay. So we have basically moved our data from HBase to MySQL to HBase. Now the next question would be, how would you copy the data back from Hive to MySQL? Okay, let's create a table in MySQL Hive called sales log file, and this must be already there. So let's launch Hive. So let's say we have a table in Hive. So let's say we have a table in Hive called sales select star from sales. Alright, so you can see the data is already there. We don't need to create it again. If you want, you can create for in your account, and then you can import that data back from Hive to MySQL. So what we need to do is, in case of MySQL, we need to create a table called sales. Okay, so we already have a table here. Let's drop the data in this table, delete from sales. Okay, so we have table, but it has no records. Okay, if there is no table, you can create the table, and this is a little time consuming process because creating a table in MySQL using Hive definition is not possible. Okay, now you can use scoop export and then give the database name, give the table name, and the directory where the data is located, and you also specify the fields determination. So basically you are copying the data from HDFS, not really Hive, from HDFS into MySQL. Okay, so this way you can, okay, so it's basically copying the data from HDFS into MySQL. Okay, so it has got a very basic set of need. It's basically for data in, data out. The only additional advantage of Scoop or the Flume over your own program is that they provide a distributed copying, which means multiple data nodes will talk to your MySQL server and push the data or pull the data. Okay, so it has exported the records. Now you can see that 4 records are there, copied. All right. Although widget IDs for some reason, uh, okay, yeah, here also it's wrong. In Hive also it's wrong. All right, then that's pretty much. Okay, here also it's wrong actually. ID is multiple times. Alright, so that was copying the data from HDFS or Hive into MySQL. Moving on. So now there is a important tool which is something which we have not thought. Although Flume, we think of Flume, whenever we think about Flume, we think about Flume as a data import tool. But it's actually a good data transport tool. Okay? And it provides a very very marvelous modularity in case you want to flow the data in your network from point A to point B. It provides really a fault tolerant system to copy the data in your network. And how does it do it? Very fault tolerant and modular. If you are copying the data which is non-RDBMS, anything which is non-relational, say in the form of files or you know a pieces of files, in all those cases you would like to use Flume. Okay, so a Flume is basically a distributed and reliable communication system. Are we recording it? Yeah, we are recording it. Yeah, it's a very distributed and reliable and a heavily available system for aggregating logs or aggregating or moving large amounts of data. So the data moves from your server to your target using an agent. Flume is made up of agents, and these agents are connected to each other in a tree structure. And so one agent behaves like an input to another, or one agent would behave like an output to another. Okay, and what does agent have? Agent is a process running on a machine. Okay, and each process of agent has one thing called source. Source is a software component which basically accepts the data from the someplace, and it starts giving the data to the sink. Okay, so if you look at it, each agent's duty is to read the data from one side and write the data to another side. And for doing this, it utilizes two components. One is source and other is sink. Sink knows how to write the data into target, and source knows how to read the data from the source. Okay? Now you might ask, then what's the point of a channel? Whatever source is reading, source and sink could have been a single component. Okay, source knows how to read the data from, let's say, your web server, and sink knows how to write that data into HDFS. So these are two parts of the agent, and this agent will keep on running on all the machines in your network. Now the question is, why do we need channel? Okay, why do we need channel? Now imagine this. On one hand, the data is coming at really fast pace. Let's say logs are getting generated in your system continuously, and source is reading those data continuously from the from the web server or logs. Okay, now these logs have to be written to, let's say, HDFS. Now HDFS says that I am slow, but if you try to write a lot of data in a single shot, then I am pretty good. Okay, so what happens is that while the sink is writing the HDFS data, the source will be waiting. And instead of that, if we create a sort of a buffer in which in which whatever data source is gathering, it keeps on writing to buffer, and in a single shot the whole data from buffer is written to HDFS. In that manner, it will be very fault tolerant, as well as it will be very fast. Okay, so that's where that buffer is the channel. That's a channel in which, so the reader, which is source, will understand how to read the data from a particular format, and then read the data, put it into channel, and then writer, which is your sink, will read the data from the channel and purge it into the target. Okay, so these are the three components which make up the agent. An agent can be organized into complex topologies. Okay, so a source could be something like tail. How many of you know tail? So tail minus f, what does tail minus f do? Anyone? Last record, that is tail, but tail minus f, it continuously reads the file. As the file is being written, it keeps on displaying the most recent lines. Okay, so for example, if you there is a log file getting generated by some tool, so you can use tail minus f on that log file and it will keep on continuously displaying whatever logs are being written into that file. Okay, so tail minus f becomes a continuous source of information for an agent. Similarly, syslog daemon can become a good source. So we can read the data from various kinds of lots and lots of kinds of input sources in agent, and then we can push it to the sink. Okay, so a combination of sink and source can be many. Let's say there is a source which reads from uh, tail, there is another source which reads from syslog, and there is another source which reads from say log4j, and then so there are three sources, and then we have sink, which there is one sink which knows how to write into hdfs, there is another sink which knows how to write into say Hive, there is third source which knows into how to write the h into hbase. Now if you look at it, we have three kinds of sources and three kinds of sinks. If you total number of possibilities are 3 into 3, so we can have nine kind of transformations, or nine kind of transport, meaning we can transport a data from tail into hdfs, hbase, and HDFS, HBase, and Hive. Similarly, for syslog, we can have the output into HBase, Hive, and HDFS, and same is true for log4j. So effectively, by modularizing, by making it very modular, we have made it possible to write the data, made it possible to create many combination of things. Okay. So that is the reason why it is made so modular. And these Flume nodes or Flume agents can be arranged in arbitrary topologies so that we basically transport data from one point to another, because one agent can become the source for another. So it's not only, so we can back to back connect these agents and get our data from point A to point B. Okay, and this is the way we generally flow the data in our network. Say we have web server, the one fleet of web servers running continuously, and we can basically create one agent on all the web servers, and then we connect these agents together so that we can flow the data from one to another and finally to HDFS. And it provides you different kinds of delivery reliabilities. Okay, so let me show you how do you generally run Flume. So Flume is a continuous process. It is not on your demand. It's a continuous process. It keeps running all the time. Okay, you start it once and then it'll read on data and keep on running it. Okay, and then you can shut it down whenever you want. All right, so this is how it is. So this is a Flume configuration file. While we'll start Flume, we will be giving this properties file and launch our service. So look at this. So this file states this file is for each Flume agent, and as you must have thought that it will have the information about source, sink, and channel, and that's what it is. So we are giving the name to this agent as A1. It says A1.sources equals R1, S1, and C1. Just these are arbitrary names. Now we describe what does it mean by R1. So we say A1.sources.R1.type is netcat, meaning it will start a server, it will start a service at this particular port on which we can start writing the data to. So right now, our source is basically a network service which will start and will wait for data to come onto that port. Okay, that's what it says. It says run netcat on this particular host and this particular port. Okay. Now what is our sync? Sync right now is our HDFS folder. You can see this is our HDFS folder. And we have channel. Channel is of memory type, which means it will be writing the data into the memory instead of instead of persisting it anywhere. So in case the system shuts down in between, the whatever data was there in the channel will get lost. All right. And this is our, now again, here we have informed agent about, here we have informed agent about its sources and sinks. Here we can also have more number of sources here. Okay, we can have R2, R3, and we describe R2, R3 below. So we can have multiple sources to suck the data from various places. Now here, so now let's launch it. Let's log in into the server and launch it and see what's going on. Okay. Yes. So yes, Srinivas, you are right. So there is a possibility of getting a memory overflow error in case of using in-memory channel. That's why in-memory channel is rarely used. Okay. Now let's go to where is our folder. Our folder is into sgiri. Then there is Flume. Okay. So here in the conf, we have our Flume properties. Okay, the same Flume properties what we have talked earlier. So what does it say? It says the specified configuration file does not exist. Okay, what was the name? So we don't have to specify. I can go up a bit. Yeah. So this slash at the end of the line, it basically to break the line, because when you have multiple one SSH command, any shell command in multiple lines, we can put backslash and then it'll do the job. Now it has started the source on 44444. Okay. Now, and parallelly, let's open in the browser our HDFS. Okay. All right. And so where is our, so we said in our configuration that we are going to write data into this folder, right? Let's go to that folder. So there are already two files here. Let's just delete it. Delete it. All right. Now here, as we have, now let's connect to the, we say telnet, or we can say nc localhost, and we have 44444. So basically we are connecting to localhost. Now it's ready, it's connected, and as we are typing data here, it will go into disk. All right, it will go into the disk. As you can see here, it will appear here. I just refreshed my HDFS folder. Please, I'm just typing some random data. Please update your browser. So you can see that the data is coming here. Yeah, one is TMP folder. So you can see as we are typing data here, data will go into the disk. You see that? That's what we typed here. Okay. So continuously, as we are writing here, the data is actually going into the disk continuously. Okay, and okay, in the similar manner, the way we are feeding data to the agent, many other machines will connect to the agent and will start writing, and will keep on creating one file for each client, and after some time it will also change the file name for. So this is, it's basically doing a lot of things for us. Okay, so now let me just disconnect it. Alright, so that's how we basically pump the data from all the services into HDFS. Okay, if you have lots of devices which are whose only purpose is to connect to a particular port and write the data into it, then what you can do is you can simply create a source which listens to that particular port and start listening to that data. And that case is very true in case of log4j, syslog, and there are many devices which you can absorb the data from. Okay. No, it support, this is not text file format. It supports the format called the bytes writable. Hadoop provides a format called bytes writable. It is writing the data in that format. All right. So you can basically do this kind of job using Flume. All right. So that was Scoop and Flume. So any questions for me? Next session, next Saturday, Sunday is going to be quite intensive in the sense that we will discuss in detail about Apache Spark, and we will also discuss in detail about Mahout. Not in detail, but at least the overview of Mahout. So be ready with that, and we'll talk about Uzi, and probably next weekend we will conclude our sessions. Okay? All right. Can we change the format for writing data using Flume? Yes, you can change the data. You have in this config file, you can mention in what format a sync is supposed to write the data. Okay? So here you can mention that format. If you want to do it in the plain text, it will write it in the plain text. Okay? So it all depends on the sync, the configuration of sync, which sync are you using, and that sync will do the job for you. All right? All right, thank you very much and have a great day. Feel free to, if you have any questions, feel free to let us know. All right. Thank you, Anand. Thank you, Srinivas. Thank you, Manish. Thank you, Lakshmikant. And have a great day ahead. All right. All right. So we'll send you a form. Please fill that one as the feedback for today. Okay. The connectivity has been an issue. I completely agree. And we need to, not only connectivity, there were two problems. Okay. All right. Thank you, Anand. Bye bye. Have a good day, all of you.